Amchitka Island, far out in the Aleutian Island chain of Alaska, was the scene on October 2nd, 1969, at 12:06 p.m. Bering Daylight Time, when the United States Atomic Energy Commission detonated the Project Milrow nuclear explosive. The nuclear explosive device, buried 4,000 feet beneath the surface of the island, had a yield of about 1 megaton, or approximately the same as some of the largest underground nuclear tests in Nevada. Milrow was a calibration test. Its effects were measured to determine if larger nuclear devices could be detonated safely at this remote island. Results showed that it is safe to conduct larger tests, and one is tentatively scheduled for the fall of 1971. This test is called Cannikin. The primary testing location for the Atomic Energy Commission is in the vast areas of the Nevada test site, where contained underground nuclear tests have been conducted since 1957 to aid in the development of advanced weapons. As national defense requirements developed, it became apparent that the Nevada test site, within about 100 miles of Las Vegas, could not be used for some necessary higher yield tests because of possible damage to off-site structures from ground motion. Many new remote areas were examined: mountain basins in Wyoming, remote grazing lands of New Mexico, and far-off sections of Alaska. After careful consideration, 3 potential supplemental test areas were identified. They are the Hut Creek Valley in central Nevada, about 90 miles north of the present test site; the north slope of the Brooks Range in Alaska, well beyond the Arctic Circle; and Amchitka Island, far from the Alaskan mainland in the Aleutian chain. Amchitka was selected as having a potential for development as a location for higher yield tests. Nearly 1,400 miles from Anchorage and 2,600 miles from Seattle, it is isolated from any populated areas. The closest persons live about 200 miles away at military bases on the islands of Adak and Shemya. Amchitka is located at about the same latitude as London, England, and farther west than the Hawaiian Islands. It's 42 miles long, 3 to 5 miles wide, and forms part of the southern boundary of the Bering Sea. The southern end of the island is low, but the higher northwest end has peaks up to 1,200 feet. The central section is mostly rolling tundra and flat tableland. Amchitka has not had full-time inhabitants for 100 years or more, but twice before has been used by agencies of the federal government for defense purposes, a role that was recognized in 1913 when the island was made part of the Aleutian Islands National Wildlife Refuge. The executive order said in part, "The establishment of this reservation shall not interfere with the use of the islands for lighthouse, military, or naval purposes." During World War II, extensive facilities were built here to house 10 to 15,000 men. Many reminders of their presence on the island are visible today. In 1965, the island was temporarily re-inhabited when the Department of Defense conducted Operation Longshot, an 80-kiloton underground nuclear detonation in a program to improve our ability to detect, locate, and identify underground nuclear explosions. The AEC cooperated in that experiment. AEC activities on Amchitka began in 1967. and new facilities have been developed at Constantine Harbor for receiving supplies and equipment by seagoing barges. The relatively warm Japanese current keeps the island waters free from ice during the winter months. But the trip along the coastline from Seattle to Anchorage and out to Amchitka passes through some of the roughest waters used for commercial shipping. The Aleutian chain has some of the worst weather in the world. Storms and high winds pass through the area every day. Very seldom can clear weather be found over the entire island at one time. Since the AEC work began, aircraft visit the island frequently and make use of a reconditioned World War II runway. The addition of modern runway lighting and ground control approach radar makes landings possible in all but the worst weather. Amchitka is accessible and workable on a year-round schedule. Base Camp, the Center for Construction and Support Activities, is located on the southern end of the island near the airstrip. Offices, warehouses, and general shops are located here as well as the main living quarters. Extensive use is being made of existing structures on the island. 2 large aircraft hangars have been repaired for use as covered storage and maintenance shops. The hostile environment of Amchitka requires protection from the elements and continuing program of repair and maintenance for vehicles and equipment. Facilities installed by the AEC are temporary. Many of the units are designed so they may be removed when the Amchitka program is completed. Living quarters for up to 750 men have been installed in the base camp area. Covered walkways protect occupants from the elements as they move between the dormitory-style trailers and the cafeteria and recreation area. When AEC activities started on Amchitka, only a jeep trail known as Infantry Road led to the northwest end of the island, where the control point for conducting nuclear tests was to be established. Now an all-weather road has been completed along the same route. Constant maintenance work is required to keep it open. It is slippery in the summer, and during the winter months, snow often drifts 10 to 20 feet high. In all construction activities, the AEC has attempted to utilize areas used during the military occupation of the island to avoid fresh damage to the tundra whenever possible. Microwave relay stations keep the northwest end of the island in communication with base camp. Early in 1969, a cable was laid to carry the firing signal and to relay data from the Milrow test location to the control point. Project Milrow was designed to yield the answer to whether Amchitka could accommodate safely one or more higher yield tests necessary for our national defense program. Preparations for possible nuclear tests included drilling several large diameter emplacement holes on the island. Holes up to 120 inches in diameter and 6,000 feet deep have been drilled using some of the largest and most powerful drilling equipment of the world. The geology and hydrology of the test sites were thoroughly investigated and found to be satisfactory for testing. Since Milrow was to be a calibration test, a nuclear explosive device of known yield was used. The actual site for emplacement of the device was approximately 4 miles northwest of the base camp area in a vertically drilled hole 4,000 feet deep. With the explosive device at the bottom of the hole, A careful refilling or stemming of the hole began. Alternate layers of sand and gravel, thoroughly dried by special processing, were fed from sealed rubber containers onto a conveyor belt until the 4,000-foot depth of the hole had been filled. This careful layering is provided so radioactive materials formed by the detonation will not reach the surface through the drilled shaft. The methods for containment of radioactive materials have been developed over a number of years at the Nevada test site. The successful application of these methods in previous higher yield tests, including 4 tests in the megaton range, has led to a high degree of confidence in the ability to assure containment in tests such as Milrow. No underground test conducted by the AEC with a yield of more than 50 kilotons has ever resulted in accidental venting of radioactivity to the surface. When Amchitka Island was chosen as the site for an underground nuclear calibration test to determine the suitability of the island for possible later tests of higher yield, an intensive program of studies began. Participating in the investigations were scientists and technical people from many federal agencies, universities, the state of Alaska, and private consulting firms. More than $5 million has been spent on safety studies and related safety effects evaluations. The studies were designed to evaluate possible effects of a nuclear detonation on the ecology of the island. Involved in the studies were tundra, wildfowl, and the fish and other life in the many lakes and streams on the island and the coastal waters surrounding it. Extensive studies have been made on seismic activity in the vicinity of Amchitka. Although the island is located in an active seismic area, the best scientific evidence available to seismologists and other scientists indicate that the possibility of any connection between underground nuclear testing and unusual seismic activity beyond the immediate area appears to be quite small. Archaeological surveys and excavations were conducted that will benefit future studies into the history of Amchitka and the Aleutian Island chain. 76 sites of historical interest were located, and 6 of these, near the Milrow test hole, were excavated. Battelle Memorial Institute at Columbus, Ohio, was delegated the major responsibility for conducting bioenvironmental studies. Part of the program included trapping of sea otter for scientific study and live transplant to other areas in cooperation with the state of Alaska and Department of the Interior. The studies were made to provide a base for predicting, evaluating, and documenting possible effects of the test. A further purpose of the studies was to determine appropriate measures to be taken in the highly unlikely event of an accidental escape of radioactivity following the test. Particular attention was given to fish of commercial value, such as salmon, halibut, and the Pacific Ocean perch. All species of fish in the waters surrounding Amchitka were examined and documented before and after the Milrow test. Shrimp and crab in the area were studied, as well as the sea otter, bald eagle, peregrine falcon, emperor goose, and various duck species. Due to the migratory patterns of much of the area's wildlife and the limited fishing season in waters surrounding Amchitka, it was determined that testing could be conducted safely and with minimal impact on the environment. Bioenvironmental information resulting from these studies has been published and is available to the public. To respond to many questions from the public and international concern which had been expressed over the possible results of Project Milroe, the AEC established an information center in Anchorage, Alaska, to provide up-to-date information on the planning and execution of the test. Questions regarding ground motion, possible tidal waves or tsunami, radiation, and environmental effects were answered by recognized authorities in these fields who formed a special panel to assist in predicting the effects that might be expected. As with all nuclear tests, the final preparations for Milroe included evacuating from the island all persons not required for the test. Helicopters removed all but about 150 men to an offshore ship where they waited until the test manager gave the word for re-entry to begin. An unusually clear day favored the time selected for the test. All dry runs and other preparations were completed. The test area was deserted, and the only people left on the island were gathered at the control point about 28 miles from ground zero. As the hour approached, live radio broadcasts from Amchitka were made to press representatives and officials assembled in Anchorage and interested listeners around the world. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 Scientists' predictions based on results of the earlier studies proved correct. Ground motion from the nuclear detonation caused some damage to a few cliffs and sea stacks that were used as perches and nesting places for some of the island's birds. But within 3 hours, bald eagles were observed perching on the sea stacks again. Captured sea otter had been placed in holding pens both on the seashore and in the ocean at varying distances from ground zero, some as close as 5,000 feet. The otter appeared unharmed by the test, and as usual, they were ready to eat voraciously as soon as food was given them. No overpressure effects were reported on any of the sea otter, including one that died, apparently from handling stress. Some fish species under study were placed in live holding boxes to determine what effect overpressure and shock might have upon them. After thorough observation and examination, the fish were released with the exception of one Dolly Varden char that had died with no indication as to cause. Some small stickleback fish were killed by overpressure in lakes near ground zero, though Dolly Varden in the lakes all survived. Along the coastlines near ground zero, some rock falls and peat and debris slides occurred, but helicopter observation and studies of shoreline photography could not detect any resultant damage to the island's fish or bird population. Scuba divers from the University of Washington and the U.S. Department of the Interior revisited underwater locations in areas near Ground Zero to photograph and observe previously placed markers on the ocean floor. Their observations indicated no noticeable change in the location of the ocean bottom markers. There was no evidence of damage to the ocean floor in the immediate vicinity of Amchitka following the detonation. AEC scientists had predicted there would be no release of radioactivity into the surrounding waters, and none has been measured. At Surface Ground Zero, the building that housed the instrumentation cable terminals and other diagnostic equipment was damaged. Earlier predictions were that it would most probably collapse. A utility trailer stationed nearby was almost demolished. Within 3 hours after the detonation, workmen and others returned to the main camp and resumed work. There was only minor damage to base camp facilities located just 4 miles from the test site. As publicly predicted, ground motion was felt as fairly strong by personnel at the control point, 28 miles from Ground Zero. But the motion was barely perceptible to observers on ADAC, about 200 miles away. No water waves or tsunami effects were measured other than a very slight ripple noted near Amchitka. At 37 hours after the detonation, a shallow saucer-like subsidence formed on the surface near Ground Zero because of the collapse to the surface of the large spherical cavity formed 4,000 feet below. Following underground explosions of similar magnitude in Nevada, many small aftershocks have been recorded on sensitive seismic instruments. While a similar increase had been expected in the vicinity of Amchitka, seismic activity after the collapse appeared to be about normal for that region. Hundreds of tiny tremors, many of them associated with cavity collapse, were recorded during the first several hours after the event. This seismic activity stopped when the broken rock above the explosion-induced cavity collapsed to the surface. In all areas of concern, the Milrow nuclear calibration test on Amchitka had effects about as predicted and indicated that the island would be suitable and safe for future nuclear tests of higher yield. The next test, tentatively scheduled for the fall of 1971, will be Kennecken, which will have a yield of less than 5 megatons. Analysis of the Kennecken test results will continue for some time after the detonation. Following the test, a drilling program will begin to recover samples from the detonation zone underground for radiochemical analysis at the laboratory. Bioenvironmental programs will continue over a number of years to see if there are any changes in the ecology resulting from underground nuclear testing at Amchitka.